Hello everyone, today we will talk about hypothesis testing. Let's start with the definition of a hypothesis. A hypothesis is a statement, claim, assertion made about the numerical value of a population parameter. If someone says that I believe the mean potency of an antibiotic meets the minimum allowable potency of 35, this is a hypothesis, because it is making a claim about a population parameter. In particular, it is making a claim about the mean potency of an antibiotic. And here, the population parameter that we are talking about is mean potency of an antibiotic, and we show it with the letter mu. And we make a claim about the numerical value of this population parameter, which is 35. So the claim that we make is called hypothesized population mean, and it is denoted by mu null. So in this case, the hypothesized population mean is 35. Okay. Now let's see other examples. The steel cables that a manufacturer produces have an average breaking strength of 5,000 pounds. So the average breaking strength of the steel cables that a particular manufacturer produces is our population parameter mu. And we make a numerical claim about this population parameter, which is 5,000 pounds. So it is a hypothesis. Second example, the light bulbs that a company produces typically last more than 1,000 hours. Again, the population parameter is the average time that the light bulbs last. And we make a numerical claim about this population parameter, which is 1,000 hours. So it's a hypothesis. And the hypothesized population mean is 1,000 hours. Why do we use hypothesis testing? Which is a part of inferential statistics. We use inferential statistic techniques because when we would like to get information about a large population where it is difficult to reach every member of the population, we use inferential statistic techniques. In particular, when we want to estimate a parameter using this population, in our case mu, population mu, it is difficult to calculate mu, and in almost all cases the value of the mu is unknown. Let's assume that mu in this example is 30, which is unknown. And to estimate mu, what we do is we take a random sample from the population. And from this random sample, as we did earlier, we calculate descriptive statistics. And let's assume that the sample mean for this random sample is 20. And we show some random sample mean as x bar, y bar, z bar. And let's assume that we take another sample. We will get x bar, the sample mean 25. If we get another sample, we may get 32. If we get another sample, we may get 27. So sample mean will change from sample to sample. So which sample mean should we trust? There is no answer for this. What is true is there is variation from sample to sample. And in order to make an inference using random sample about the population, we need to use this variation from sample to sample. And some of the techniques that use this variation from sample to sample are confidence intervals, hypothesis testing. This week we will talk about hypothesis testing. Now, when we are given a hypothesis statement, a numerical claim about a population parameter, we should define is we should define it using statistical language. Okay, in statistical language, we define a hypothesis in two parts. H null, null hypothesis, H sub 1, or sometimes as denoted by H sub A, is alternative hypothesis. Okay, note that a hypothesis is always a population parameter, which we do not know, which we try to estimate. So a hypothesis is about population mean, mu. It's not about sample mean. Samples are small, we can calculate sample means, so there is no uncertainty about the sample mean. What we are trying to estimate is mu. So the hypothesis statements include, the hypothesis statements about the means include mu. Okay. Now, the null hypothesis is a statement of no difference, no effect. As its name implies, null hypothesis corresponds to the null condition for a hypothesis statement. Okay, it is generally stated as an equality. So in our case, H null is mu is equal to mu null, where mu null is hypothesized population mean. In our case, it is H null is mu is equal to 35. Now, the alternative hypothesis is the hypothesis that includes the main thesis of the study. Okay, it can be defined in one of three ways. H1 is mu is greater than mu hypothesized mean, mu is less than mu null, and mu is not equal to mu null. If it is defined as mu is greater than mu null, it is a right tail test. If it is mu is less than mu null, it is a left-tailed hypothesis. And if it is mu is not equal to mu null, it is a two-tailed hypothesis. Now, to test, let's see with an example. To test the claim that mean potency is greater than 35. Okay, null hypothesis is a statement of no difference, so it is mu is equal to 35. Now, when we define alternative hypothesis H1, we look at the main thesis. Main thesis is greater than. So, in the alternative hypothesis, we should use mu is greater than 35. Okay. Now, if the claim were the mean potency is less than 35, okay, how would we define the hypothesis? H null is mu is equal to 35. It's a statement of equality. And H1 is mu is less than 35. Okay, if you test the claim that mean potency is different from 35, okay, H null is mu is equal to 35 always, and H1 is, we are trying to test whether the mean is different from 35, whether or not it is equal to 35, so it is mu is not equal to 35. Please note that there are some resources that define the null hypothesis H null as the opposite statements, as the opposite statement of H1. For instance, here, depending on the main thesis, they define H1 as mu is greater than 35. Then they define null hypothesis as the opposite of this. So they define it as mu is less than or equal to 35. Defining the null hypothesis as an equality statement is the most commonly used way, and it is what our course book follows. So I will go with defining the null hypothesis as an equality statement. Okay, now once we define the hypothesis, we need to follow a formal hypothesis testing procedure in order to test our hypothesis. Now, it's a step-by-step procedure, and in the first step, we define the null and alternative hypothesis. We define the null hypothesis as a statement of equality and alternative hypothesis depending on the main thesis. So it can be either defined as a two-tailed test using an inequality sign, as a left-tailed test using a less than sign, or as a right-tailed test using a greater than sign. And second step is selecting a level of significance alpha. This level of significance helps us make a decision. Okay, it is a threshold value and it is provided in the question. It is given. And 0.05 is the most commonly used significance level. Now, step 3 is computing a test statistic. It's a t-test statistic, and it measures the deviation of x bar, the sample mean, from the hypothesized population mean in the non-hypothesis, and to decide whether or not this difference is large, it divides it by the standard deviation. So it is a t-score. Indeed, a t-test statistic is a t-score, okay? And it is the deviation of the sample mean from the hypothesized population mean in terms of standard deviation. Next step is to calculate the p-value corresponding to the test statistic. P-value can be calculated by hand or using technology. We will use technology, and p-value is the likelihood or probability that measures whether the test statistic is likely or unlikely, assuming that H null is true. Okay, once we determine the p-value, step 5 is making a decision. Please note that we make a decision in terms of the null hypothesis, H null. In particular, as a decision rule, if p-value is less than alpha, the probability that the sample data supports the null hypothesis is very small, so we reject H null. If p-value is greater than or equal to alpha, it means that the sample evidence is large enough to support the claim in H null, so we do not reject H null. Either we say we do not reject H null, or we say we fail to reject H null. Okay, so if p-value is less than alpha, we reject H null, and if p-value is greater than or equal to alpha, we do not reject H null. Now the final step, step 6, is state the conclusion, and we state the conclusion in terms of H1. Remember, H1 includes the main thesis of the study. So if p-value is less than alpha, we reject H null. So we have two hypotheses, we support either one of them. So in case we reject H null, we make a conclusion in favor of H1, alternative hypothesis. Making a conclusion in favor of H1 means saying something like, there is sufficient evidence in the sample data to make the claim in H1, okay? If, on the other hand, if p-value is greater than or equal to alpha, we fail to reject H null. So we are stuck with H null, and in this case, we make a conclusion against H1, against the main thesis. So we say something like, there is not sufficient evidence in the sample data to make the claim in H1, okay?